Here we have another logarithmic differentiation example problem, and we want to differentiate the following, where we have these two different functions that are multiplied together. And so in previous lessons, we could go ahead and use the product rule to evaluate the derivative for this, but it might be a little bit messy, and there's an easier way to evaluate this derivative. So we're going to talk about using the natural logarithm to solve this. So we can go ahead and take the natural logarithm of both sides, and then we can use the properties of logarithms to simplify this right-hand side. So we can go ahead and notice that this is a multiplication, and so we can separate them by having an addition sign. So we have the natural logarithm of the first term and the natural logarithm of the second term. And then the final step in using our properties of logarithms is we can take this exponent and put it out in front. So that's another property that we can use. And we know that this square root term is really just a 1/2 power. So we can have this 1/2 power in front as well. After having the natural logarithm of all three of our terms, we can go ahead and use implicit differentiation to solve for the derivative. So here we have d dx of y, which is going to be equal to 7 d dx of ln of 5 minus 3x squared. And we were able to factor out this 7 since we know that it is a constant, and then that's going to be added to 1/2 d dx of ln of 6x squared plus 8x minus 12. And so now we have something that's a lot easier to take the derivative of. So we can go ahead and take the derivative of these three terms, and we'll get 1 over y prime for our first term. We'll get 7 multiplied by negative 6x divided by 5 minus 3x squared, and that's by taking the derivative of the natural logarithm here. We know that really it's just the derivative of this inside term divided by what is contained within the parentheses. And then we'll do the same for the rightmost term as well. After that, we can go ahead and continue our simplification process by combining like terms. So you can see here, that's what we have after simplifying. And then we'll go ahead and multiply this y term to the other side. And our last step is we want to back substitute our original y term into this y position. And what we're left with is our solution for the derivative.